Now, children who have conduct problems and high levels of callous unemotional traits have difficulty in recognizing and reacting to other people's emotions, particularly emotions of distress such as fear and also sadness, which is what you see here at the top right-hand side, bottom right-hand side. And people have used facial stimuli, such as what I just showed to you, to assess this, but people have also used stimuli that is auditory, so people doing vocalizations that are emotional, or body postures. And this work by our lab and labs of our colleagues have very conclusively shown that these children really do not appear to process other people's emotions in a typical fashion. They seem to be underreactive to these displays of emotions and unable to recognize them as effectively as typically developing children do. Interestingly, they also report feeling less fear themselves. And one of the things that we're interested in researching in our lab at the moment is whether the reason they have such difficulty in processing other people's emotions stems from the fact that they don't feel those same emotions very strongly themselves. So it's probably trickier to empathize with other people and to recognize their emotions if you have an impoverished experience of those same emotions yourself. We also know from standard learning paradigms that these individuals who have conduct problems and high callous unemotional traits are less responsive to punishment. So when you have to learn about which stimuli is good to go for and gives you points and which stimuli is bad to go for and doesn't give you points, these individuals are typically poorer at modulating their behavior in response to the punishment cues. And people have theorized that one of the reasons why these children may be tricky to socialize is that two very powerful tools of socializations are not as effective for them. So anyone who has small children in the audience or has dealt with small children knows that when they misbehave, we often give them sanctions. So in my house at the moment with the 3-year-old, we have a naughty step and he sits there relatively regularly. So it's something that I employ in my house. It's very effective. He doesn't like sitting on the naughty step. He said he'll kind of improve his behavior, and he usually comes and joins us, and he indeed does improve his behavior because he doesn't like being excluded from the activities. We also do empathy induction. So anyone who's dealt with toddlers has basically repeated, well, think how Johnny's going to feel if you whack him with the toy car, until they blew in the face. So we try and get the children to focus on how their behavior might impact somebody else and somebody else's emotions. Now, if you are really incapable of feeling perhaps those emotions yourself and also feeling for other people, and if you don't react very much to punishments, there are two very powerful socialization tools that are not going to be as effective in bringing you up as they are in typically developing children. So really what we see in these children is this diminished emotional responsivity to both kind of more material punishments, but also in terms of their reactivity to other people. And this profile is in contrast with the profile we see for children who have conduct problems, but who have low levels of callous unemotional traits. These children, if anything, seem to be a bit emotionally overreactive. They have what psychologists call a hostile attribution bias. So they tend to see threat in even stimuli that typical individuals don't perceive threatening. So they might see an ambiguous face and think that this is somebody who's trying to get at me, so I'm going to aggress first. So in this group, what we see really is increased emotional reactivity, at least to some types of stimuli. And these data have got ourselves and also other groups interested in looking at how these children's brains look like when we show them emotionally charged stimuli. One of the ways in which we can study how the brain processes information is by scanning children using functional magnetic resonance imaging. This is a non-invasive technique that involves scanning the children's brains as they lie inside the magnet, and they do tasks that we have set to them. We can then look at their brain activity as they are doing the tasks, and this gives us an idea of what parts of the brain are engaged in processing the information that we show them. One of the brain areas that researchers on conduct disorder or conduct problems have focused on is called the amygdala. And this is a very small, almond-shaped part of the brain. It's a very preserved structure. Even reptiles have it. It's there for basically alerting you that there's something salient in the environment that you ought to pay attention to. And this salient information for us human beings includes emotions of other people. And studies of children with conduct problems using emotional stimuli have been a little bit mixed. Some studies have reported increased amygdala reactivity to emotional stimuli. Other studies have reported decreased amygdala reactivity to emotional stimuli. And our group recently wanted to investigate whether it's the callous unemotional traits that determine whether the children's brains are under-responsive or the amygdalas are under-responsive to emotional stimuli or over-responsive to the same stimuli. So we have carried out a range of paradigms recently. I will talk about 2 here in the talk. Here is an example of a recent task that we've used called masked fear task. And in this task, we presented either fearful faces, which are on the left-hand side there, or calm faces, which are on the right-hand side there, for a very short duration, only 17 milliseconds, and then we replaced those faces with a calm face of a different identity. And the replacement of the face happened so quickly that the participants are not consciously aware that they've seen a fearful face. So the advantage of this task is that we can look at very early pre-conscious processing of emotion. In other words, we get an idea of how automatically the brain attunes to the emotional stimuli. And when we contrast the fear and the calm conditions, we find a pattern of brain responses where children who have conduct problems and high callous unemotional traits show very low amygdala reactivity to these pre-consciously presented fear stimuli. The typical children are somewhere in the middle, and the children with conduct problems and low callous unemotional traits show, if anything, overreactivity to these fear faces that we present pre-attentively. And here I'm showing you a plot of the data from the children with conduct problems alone. And on the left-hand side, on the y-axis, you can see the brain activity estimates from the fMRI analysis. And on the right-hand side, you can see the child's callous unemotional trait score. And you can see that the higher the callous unemotional trait score, the lower the amygdala response to these fearful faces. We've also used more complex emotional tasks, such as tasks that showed scenarios of other people in distress. So this was a cartoon task where the children saw a scenario where the mother is reading a newspaper, a child is going down a slide, and the child ends up hurting himself and falling off the child. And then the person inside the scanner gets 2 choices as to what is the appropriate ending to the task. And most children, even the children with conduct problems, are very able to say that the appropriate response is for the adult to go and comfort the child. So behaviorally, the children process this task very similarly. But interestingly, again, the amygdala of the children with conduct problems, particularly those children with conduct problems and callous unemotional traits, is less reactive to observing other people in distress in this very complex social scenario. And the kind of contrast we give in a scanner is we have similar scenarios but without the emotional content, so we can really extract the emotional response of the brain. So the data from these behavioral, psychological, and brain imaging studies is really showing this picture of shallow affect and lack of empathy and demonstrating it in different levels of analysis. So we know from naturalistic behavioral settings, from more experimental behavioral settings, and also from brain imaging settings that these children really seem to have this underreactivity to other people's emotions, perhaps particularly distress. So these sort of data obviously begs the question as to why do these children process the information around them so differently? Are they genetically at risk for being this way? Are there some environmental risk factors that mean that they come to be very unempathic, very emotionally underreactive? And one of the ways in which you can probe the origins or the etiology of any given trait or disorder is by classical twin design. And the twin design relies on a comparison between identical or monozygotic twins and non-identical or dizygotic twins. The identical twins are a result of a single fertilized egg splitting, so they are, for all intents and purposes, each other's genetic clones. And an example I often use here, I run the research group with Dr. Eamon McCrory, who's an identical twin, and his brother has 3 children, but if they did a paternity test, they couldn't tell whether it is the brother or whether it's Eamon who's the father. So these are 2 individuals who have identical DNA. Then we have non-identical or dizygotic twins who are the product of 2 separate eggs being fertilized by 2 separate sperms. So they are like any other sibling pair, but they have been born at the same time, which makes them a good comparison in the studies for the identical twins. And you can use the twin studies to infer the relative importance of genetic and environmental influences on variation on any given trait. And the way you can do it is you can compare how similar do these clones look to each other on any given behavior, and how similar do these non-identical twins look to each other on any given behavior. And you can conclude that there is more than likely to be genetic influence on a trait if the identical twins look more similar to each other than the non-identical twins. So if genetics are important in driving similarity, then the individuals who share 100% of their DNA should look more similar to each other than individuals who share on average 50% of their DNA. You can also conclude that there may be environmental factors that make family members similar to each other if the non-identical twins correlate with each other or resemble each other more than the half of the identical twin resemblance. So if you think that only genetics are important for driving similarity, then the dizygotic twin resemblance should be exactly half of the identical twin resemblance. Now, if the dizygotic twin resemblance is actually larger than half the identical twin resemblance, this tells us that there are some environmental factors that act over and above genetic factors to promote similarity between family members. And we can also infer that there are some individual-specific or non-shared environmental factors if the identical twins are not 100% identical on a trait. So these are each other's genetic clones. To the extent that they differ on any given feature, there must have been some environmental influences that differed between the twins. And an example I often use to drive this point home is if you imagine an identical twin who grew up in Britain versus an identical twin who went to live in Australia, you would expect that there are changes and differences in pigmentation between these twins, because one of them is exposed to constant sun and the other one has to deal with the kind of weather that we've been having last week. So this is environmental factor that differed between the twins and drives differences between family members. And we have used the twin design to ask whether there are differences in the